All right, so we're in section 7.5. We're going to talk about the side-splitting theorem. Side-splitting theorem is related to what we talked about a while back about midsegments. So our side-splitting theorem says that a line parallel to one side of a triangle divides the other two sides proportionally. And remember that proportionally means same ratio. So let's draw a picture. So here's our triangle. We have a segment in the triangle that is parallel to one side of the triangle. So that's our setup for the side-splitting theorem. I'm going to call this side A, B, and this segment D, and this C. Oops, C. So the side-splitting theorem tells us that these two sides are divided proportionally. So I'm going to say some proportions are, and I'm going to call this whole side X and this whole side Y. So I can say A over B. I can compare these two sides. That is the same as D over C. I could also go across a triangle. I could say A over D equals B over C. So these two, and these two. I could use the entire lengths. I could say X over A. That has to be the same as Y over D. I could say X over Y, this whole side divided by this whole side, is B over C. So all of these are different proportions that we get from the side-splitting theorem. When we talked about midsegments, do you remember how the midsegment divided this side of the triangle? The midsegment was in the middle, divided this side of the triangle in half. And the midsegment, when the segment is in the middle, it's half as long as the base of the triangle. So midsegment is a special case of the side-splitting theorem. Midsegment is when our ratio is 1/2. All right, so let's look at a couple of examples that have to do with the side-splitting theorem. All right, there is our setup, and we want to find X. So we have that this segment is parallel to the base of the triangle. So we know it divides the sides proportionally. 6. So let's write a proportion. We're in chapter 7. Let's write a proportion. So what kind of proportion do we want to write? Who can help me out with a proportion? This is a 9. So 9 over 6 equals 3 over x. That will work. Then we cross multiply. 9x equals 18, divide by 9, and x equals 2. Could I set up that proportion differently? We could say 9 over 3 equals 6 over x. And we get the same thing. 9x equals 18, and x equals 2. So as long as you compare corresponding sides, corresponding pieces, you get the same proportion, and you get the same answer. So there's a lot of ways you can set up the problem. All right, let's look at another example. I'm going to call this 3 and this 4 and this 2. And for this one, I'm going to call this whole side x. And we want to find x. We have these segments parallel, so we can use the side splitter theorem. So we need to set up a proportion. We know the sides are divided proportionally. Well, this x is the whole side of the triangle. So if we want to make a ratio with this whole side of the triangle, we need to know the whole side of the other side of the triangle. So what did that be? 7. Those, we could add those together. So then I can write a proportion. So how do I want to write my proportion here? 7 over x, this whole side to that whole side, equals, since we start on this side's on the top here, we want whatever's on this side to be on the top here. So since we know about these two sides, I would say 3 over 2.
Why?
Because for my ratio, I have the long side here on top and the long side here on the bottom. So I want whatever piece for the ratio I'm going to write here, I want the top part of the triangle to be on the top of the fraction. You need to keep the fractions in the same order. Cross multiply, 3x equals 14, and x equals 14/3. I could solve this a different way. I could figure out what this length is. If this whole side is x and this bit is 2, how much is left for this side? X minus 2. So if this were 10 and this were 2, this would be 8. If this were 15 and this were 2, this would be 13. So this side is x minus 2. And then I could set up a proportion using that. I could say 3 over 2 equals 4 over x minus 2. And if I did it that way, I would get 3 times x minus 2 equals 8. Distribute here. 3x minus 6 equals 8. Add 6 to both sides. And I get 3x equals 14 again. So x equals 14/3. So as long as you keep your corresponding parts in the same parts of the fraction, you get the same answer. And there are other ways that I could set this up. These are the first two that jumped out at me. Yeah. We have a couple more things to talk about. Yes. All right, questions on this? All right, let's talk about a corollary. And remember, a corollary is just a theorem that we can figure out easily once we know our original theorem. All right, our corollary is, this time we're going to have 3 or more parallel lines. And our three or more parallel lines are going to divide intersecting transversals proportionally. So what we have for this problem, we have intersecting transversals, like so. And we have three or more parallel lines. So I'm just going to use 3. So those lines are parallel. Here are my intersecting transversals. So really what I have is this creates several different triangles. So that's why we call this a corollary. If we get triangles, we can use the side-splitting theorem on the triangles. So I'm going to call this A, B, C, D, E, and F. So what the theorem says is those transversals are divided proportionally. So some proportions are, I could say A over D, comparing these two, equals B over E. I could say A over C, can compare this one and this one. That has to equal D over F. So I just match the parts in the correct order, and I'm set. I could say B over C equals E over F. And I could keep going. Then we get a lot of proportions that we set up from this situation. So parallel lines and intersecting transversals just give us another way to set up proportions. All right, so let's look at an example with this. All right, if I extended those two segments, would they eventually intersect? Yeah, so those are going to be my intersecting transversals. And we're going to say all of those are parallel. There's X, Y, and 80, 40, 50, and 62.5. And we want to find X and Y. Well, these are my intersecting transversals. We know that the intersecting transversals divide the sides proportionally. So I can set up some proportions. I said, what do we want to set up? Any suggestions? 62.5 over 80. So we need one ratio that doesn't have a variable in it. So we can solve for our variable nicely. And that's going to equal 50 over y. That'll let us solve for y. So cross multiply, 62.5 y. 50 times 80 is 4,000. Divide by 62.5. And when I do that, I get y equals 64. Well, I can do the same thing to solve for x, right? That same ratio, 62.5 over 80, has to be the same as the ratio of these two sides. So that's going to be 40 over x. So 62.5 x equals 40 times 80 is 3,200. And divide by 62.5. So x equals 51, in this case 51.2. There are other ways that I could set this up. I could have said 62.5 over 40 equals 80 over x. That would work. I'd get the same answer. So multiple ways that I can set this up. All right, questions there? One more way that we can set up proportions with triangles is with angle bisectors. Angle bisector. So we're going to say the angle bisector of a triangle divides the opposite side into lengths that are proportional to the adjacent sides. So what we're saying here, we'll draw a picture. Here's my triangle. And we have angle bisectors. We know that we have angle bisectors because those two angles are congruent. It splits this vertex angle in half. I'm going to call this A, B, C, and D. So what the theorem says is the angle bisectors divide the opposite sides into lengths that are proportional to the adjacent side. So A over B equals C over D. I could also say that B over D equals A over C. Those two mean the same thing. So this just gives us another way to find proportions in triangles. All right, let's look at an example of this. I'm going to say that's 9. This is 24. This is x, and that's 25. And we want to find x. All right, so I'm going to, we know that this is the angle bisector because these two angles are congruent. So I'm going to set up my ratio 9 over x equals, well, I need to know this length. How do I figure out that length? 24 minus 9. Yeah. Equals 15. So I get 15 over 25. So cross multiply, 15x, 9 times 25 is 225. Divide by 15, and x equals 15. All right, so angle bisectors just give us another way to set up proportions in triangles. All right, questions? Okay. Homework. So that's our homework from tonight. Suggested review. I sent this yesterday, but page 459, number 3 through 12, 14, and 15 through 17. So that's a mid-chapter quiz in our book. Those are suggested review problems. I'm not going to collect the review, but the best way to study for a math test is to do more math problems. The worst way to study, one of the worst ways to study for a math test is just look at your notes. Because what happens when you look at your notes, you say, oh yeah, I know that, I remember that, I remember that. But you haven't done any problems. You need to do more problems to study for your math test. That's the best way to study.